Assalamualaikum and good day everyone. My name is Nur Faiza binti Samus and today I'm excited to presenting our group project titled Top 15 Event Spaces in Kuala Lumpur 2026. Working with me on this project are my teammate Nur Amira and Ariana Shafika. Our project is a web platform designed to help people to find the best event venue in KL. Instead of using an old school hosting, we built this using a three-tier cloud architecture on AWS. This means we separated our web server, our database, and our image storage to make the site more faster, more secure, and reliable. Our main goals were simple. The first one is to design and deploy a cloud-based web application using AWS services. The second one is to utilize Amazon EC2 as the compute service for the hosting the web application. And the third one is to store and retrieve event space information using Amazon RDS, which is also implies to the MySQL. And the last one is to store and manage event images using Amazon S3. First, we set up the IAM user so we could work together safely without sharing one password. We split the work based on the AWS services. And as for me, I handled the EC2 and S3 setup. Amira was in charge of the RDS database, and Ariana managed the networking and VPC. You can see our individual setup in figure 1, 2, and 3. In the next step, which is 3.2, we created a security group called Event Hall. Think of this as our digital security card. As shown in figure 4 and 5, we opened port 22 for our own access, while port 80 and 443 was open so the public can actually visit our website. This keeps the server safe while staying open for businesses. Finally, for our networking setup, we use the default AWS VPC, which provided us with a solid and reliable foundation without overcomplicating the configuration. In our project, Amira and I used a different AWS server as I was connected to a Singapore region server while Amira used a Malaysian region server. Even though we were using a different regions, the distance between the server is relatively close, so the network performance remains stable and the VPC communication and access work smoothly without any issue. This setup allowed both of us to develop and test our system efficiently while maintaining proper connectivity. In this figure, you will see our public subnet and internet gateway. This is the most important part because it is the bridge that connects our private AWS network to the global internet, allowing our website to go live.
Assalamualaikum, my name is Ariana Shafika. Let's continue with EC2 instance setup. This is where we launch the virtual server that will host our entire web application. We selected the Amazon Linux 2023 AMI, a free tier eligible operating system optimized for cloud application. For our instance type, we choose T3.micro, which provides one virtual CPU and 1 gig of memory, perfect for our directory website. For secure access, we generate a key pair called event key. This allows us to connect to the server via SSH without using password. We place the instance in our project with PC and assign it to the event hall security group that we create earlier in the security group configuration. Uh, we also attach on 8 gig root volume, which provide fast boot times, and reliable storage for our web server files. Once configured, we launch the instance. Within minutes, it reached a running status and passed health check, confirming that our virtual server was healthy and ready. With our server running, we move to the section 3.5, web server installation. First, we need to establish encrypted access to the EC2 instance using the private key to enable a secure remote administration of the web server. Okay, next, we need to make sure all system packages were up to date by running sudo yum. This ensure the environment has the latest security patches. Then we need to install three key components: Apache, PHP MySQL ND, the MySQL driver that allow PHP to communicate with our database. After installation, we started the Apache service and enabled it to launch automatically on system boot. Finally, we tested by visiting the server public IP in a web browser. This to make sure that our web server was reachable over the internet. Now that our web server was operational, we needed a place to store our event data. For this, we use section 3.6 Amazon RDS database setup. We choose MySQL 8.0 as our database engine because of its reliability, performance, and seamless compatibility with PHP. To maintain our zero cost goal, we selected the free tier template, which provide a db.t4.micro instance with 20 gig of storage. More than enough for our directory. Then we place the database in our project VPC and configure the security group to allow traffic on port 3306, the default port for MySQL. This ensure only our EC2 instance can communicate with the database. After launching, we connected from our EC2 terminal using RDS endpoint and administrator credential. We then created the event space DB database and verified its creation with show database. With our database ready, we proceed to section 3.7, database table creation. This is where we structure our data to store event venue information. The event space table was designed to store essential detail for each event venue, including the venue name, location, capacity, price, and image URL, link to the venue image in S3 bucket. Okay, each record in the table is uniquely identified using a primary key with auto increment. Finally, we ran select command to confirm all data was stored correctly and ready to be retrieved by the web application.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amira Binti Barisham. So next, I will explain the S3 bucket creation. To fulfill the storage requirement of our project, we use Amazon S3 to store all images of the top 15 event species. Instead of storing images on the server, S3 provide durable, scalable, and also fast cloud storage. So first of all, we created a bucket with a unique name and selected the region to ensure the faster access for users. So by default, S3 block public access for security reason. However, since our website need to display these images publicly, we disable the block all public access setting. So next, after that, we configure a bucket policy using JSON to allow the action S3 get object, and this allows users to review the images from the website without getting an error. Okay. Finally, we uploaded 15 images representing the event venues. Each image has its own object URL, which we later link inside the database. So this setup ensures that all images load efficiently and securely from the cloud. So next, moving on to section 3.9, which is database integration in web development. So our website is developed using PHP and it connects directly to the Amazon RDS MySQL database. So in the code, we define the database endpoint, username, password, and also database name. Then we establish the connection using the SQI function. If the connection fails, an error message will appear. So once connected, the system executes an SQL query to retrieve all records from the event spaces table. Okay. The retrieved data is displayed dynamically on the website using a card layout. So each card shows the event image from S3, name, description, capacity, and also location. So this dynamic integration means that any update made in the database will automatically appear on the website without changing the code. So this demonstrates how cloud services work together in real time between storage, database, and also web server. Okay, next. I will present the result of our project. So the web interface successfully display the list of top event spaces in Kuala Lumpur using a modern card layout. So each card shows important information such as image, venue name, description, capacity, and also location. So this make it easy for users to compare venues quickly. The design is clean, organized, and also user-friendly, which improve the reliability and also navigation. So the image load smoothly from Amazon S3, while the data is fetched dynamically from Amazon RDS through the EC2 web server. So overall, the system works as expected and demonstrates a functional cloud-based web application. So for the discussion session, the results show that our web application was successfully deployed using AWS Cloud Services. So this integration between Amazon EC2, Amazon RDS, and also Amazon S3 allows the system to retrieve and also display data efficiently in real time. So the card-based interface improves the user experience by presenting information clearly and also attractively. So users can easily view venue details and images without delays. So overall, the system meets the project objective and also shows practical implementation of cloud computing system. So now I will demonstrate our website for the top 15 event spaces in Kuala Lumpur. So this website is hosted on an Amazon EC2 instance. The data is stored in Amazon RDS and also all images are stored in Amazon S3. Let me show how the system works in real time. So this is the homepage of our website. At the top, we can see the title Top Event Spaces in KL 2026. Below that, the event spaces are displayed in the card-based layout. Each card shows an image of the venue, the name, description, capacity, and also location. So the images are loaded directly from Amazon S3, while the text data comes from the Amazon RDS database. So as I scroll down, we can see multiple event spaces display consistently. So this shows that the data is dynamically retrieved from the database and not hard-coded. For example, this event space information is fetched from the database using PHP. If we update the database record, the changes will automatically appear on this page without modifying the website code. So this demonstrates real-time integration between the web server and the database. The image you see here are stored in an Amazon S3 bucket. So each image has a public object URL which is linked inside the database. So when the page loads, the browser retrieves the image directly from S3, ensuring fast performance and reduced load on the web server. So the interface uses a clean and modern design with responsive card. The layout adjusts automatically based on the size screen, making it user-friendly for both desktop and also mobile devices. So the hover effect on the card is improved interactive and also user experience. As you can see, the card animation highlight the selected venue. Each card also has a book now button. Currently, this button is for demonstration purposes and represent future functionality where booking features can be added. So the system load smoothly without delays, showing that the EC2 instance is functioning correctly and also the integration between services is stable. So in summary, this demo shows how our cloud-based system successfully display real-time event space data using AWS services. So this concludes the website demonstration and also that's all from our group. Thank you and have a good day.